So finally, we're going to take a look at a summary and review of trigonometry. First thing, can you use a primary trig ratio to determine a side length or an angle measure in a right triangle? So recall our 3 steps when solving problems. We should always label our diagram, state an equation, and solve. So in our first diagram, let's label it A, B, and C. X is across angle C, and 32 is across angle A. Our angle of focus is 30 degrees. So relative to that 30 degrees, we know that X, or C, is the hypotenuse of this right triangle, and side A is adjacent to the 30-degree angle. So we need a ratio that has adjacent and hypotenuse. So for our first example, we are going to use the cosine ratio. And we're focused on angle B, so cosine B is equal to adjacent over hypotenuse, so A over C. Subbing in our values, we get cosine of 30 degrees is equal to 32 over X. This is the case where we have our X in the denominator. So what we do is we flip both sides of the equation. So we get 1 over cosine of 30 is equal to X over 32. Since we have X over 32, we multiply both sides by 32. And we end up with X equals 32 cosine of 30. And if we take 32 and divide it by cosine of 30, we get that side X is approximately equal to 36.95, so roughly 37.0 millimeters. So that is how we find a side length. Let's go to example B. Again, let's label our diagram. So let's say this is A, this is B, and this is C. So our 6 is going to be side B, and our 8 will be side A. Our angle of focus is now angle A, and 8 meters is opposite angle A, and the 6 meters is adjacent to angle A, since AB is the hypotenuse. Since we don't have any information for the hypotenuse, we're focused on opposite and adjacent. And the ratio that has opposite and adjacent in it is our tan ratio. So we have tan of A is equal to 8 over 6. Since we're looking for an angle, we need to use the tan minus 1. So angle A is tan minus 1 of 8 over 6. And we end up with angle A as approximately 53.1 degrees. All right. Second thing. Can we use the sine law to determine a side length or an angle measure in a non-right triangle? So going through our 3 steps, let's label this A, B, and C. Since we're looking for this angle here, theta, we're going to start with the sine law that has the angle in its numerator. So we're going to start with sine of angle A, which we know we have to take it over the side of A. And the values that we know is C and side C. So we're going to compare that to sine C over side C. So there's A and there's C. So same as before, let's sub in our values. So we have the sine of angle A, which is in this case theta, over 3.4, which equals the sine of 40 degrees divided by 2.7. So we have sine theta over 3.4. We want to isolate for this sine theta. So we're going to multiply both sides by 3.4. And I get sine theta is equal to 3.4 sine of 40 over 2.7, because these cancel out. Since we're looking for an angle, if I want to find angle theta, I'm going to do the sine minus 1 to get rid of that sine attached to the theta of 3.4 sine of 40 over 2.7. So therefore theta approximately equals 54.0 degrees. So that's how we use the sine law to find an angle. Notice I started with the angle in the numerator that I'm looking for. And in the second one, let's label this one again. Let's say this is A, this is B, this is C. We are looking for side X. We'll need to find this third angle, which if you use the 180 rule, 180 minus 40 plus 60, we get that angle A is equal to 80 degrees. So X is side A and B is 245. So again, we're going to use the sine law, and we're solving for side A. So we start with A in the numerator, so that has to go over sine of A. And then we have side B over sine of B. So there's the equation we're going to use. If we sub in our values, we get X over the sine of 80, because 80 is across X. And then we get 245 divided by the sine of 60, because remember 60 is across 245. Next step, we have X divided by sine 80, so we need to multiply by sine 80 to get rid of the sine 80 from the left side. And we have that X is equal to 245 sine of 80 over sine of 60. And the last step is just to use your calculator. So you get X is approximately equal to 278.6 inches. All right, last formula we used was the cosine law. And so can you use the cosine law to determine a side length or an angle measure in a non-right triangle? So step one, let's label our diagram A, B, and C. When using the cosine law, look for the angle of focus. In this case, it's angle B. So that means I'm going to use the version of the cosine law that has angle B in the equation. So let's set that up. So that's B squared equals A squared plus C squared minus 2AC cosine of angle B. So now let's sub in our values. We have B squared is 48, so 48 squared equals 46 squared plus 39 squared minus 2 times 46 times 39 cosine of theta, or we could leave it as angle B. Let's figure out what 48 squared is first. So we get 2,304. Next, using our calculator, 46 squared plus 39 squared is equal to 3,637. And the next part, or the next thing, is to multiply these three numbers. And that gives us 3,588 cosine thetas. Remember, for this one, the cosine thetas are attached to that 3,588. So I'm going to minus 3637 from both sides to get that cosine theta on its own. And that gives us negative 1,333, which equals negative 3,588 cosine thetas. Divide both sides by negative 3,588 to isolate for cosine theta. So we end up with cosine theta is approximately equal to, and remember, take these to 4 decimal places, 3715. And remember, we're looking for an angle, so our last step is to use the cos minus 1. Since there's a cosine attached to theta, to get rid of the cosine attached to theta, we use the cosine minus 1. And I end up with 68.2 degrees. All right, triangle 2. Let's label our triangle A, B, and C. So here's our side C, here's our side B, here's our side A. So the version of the cosine law we need, since we only have angle C, we need to take the version of the cosine law that starts with C squared, because it has angle C in its equation. Next, let's sub in our values. So C squared is just X, so we have X squared equals 122 squared plus 98 squared minus 2 times 122 times 98 cosine of 65 degrees. Type that whole equation into your calculator, and that gives us 14,382.35213. But then we need to square root this answer. We get that X is approximately equal to 119.9 kilometers. So we started by using our right triangle laws to solve our right triangle problems, so sine, cosine, or tangent. Then we have non-right triangles. Since we had a side opposite a known angle, we use the sine law for the next two examples. And then finally, when we did not have a side across a known angle, we used the cosine law. When solving a problem that can be modeled by an acute triangle, how do you decide whether to use the primary trig ratios, the sine law, or the cosine law? Well, first of all, of course, draw your diagram. If the diagram involves one or more right triangles, so if you see a right triangle, then you can use a primary trig ratio, or you might end up using Pythagorean's theorem. Remember, the primary trig ratios are sine, cosine, and tangent. You use the sine law if you know the lengths of two sides and the measure of one opposite angle, or the measure of two angles and any side. But I think it's easy to remember is when you have a known angle across a known side, then use the sine law. And finally, you use the cosine law if you know the lengths of all three sides of a triangle, or you know two sides and the angle between them. So below here I have what's called a graphic organizer. So I start off by thinking to myself, do I have a right angle? If I do, then I travel the upper path, and I can use sine, cosine, or tangent ratio, or the Pythagorean theorem. If I don't, then the second question I need to know is, do you have a known angle measure across a known side? If I do, then the sine law. If I don't, then my last option is the cosine law. Here are some questions you should try before you start the assignment.